So hello everyone, how are you all? In this particular video we are going to see how do we calculate number series. And number series is a very important concept that comes in most of the examinations that concerns aptitude. And what we see in generally in CRT placements, that are campus recruitment trainings, that number series is a concept wherein the student gets confused as to how he should proceed with the number series that is given. So first I would like to define what is a number series here. A number series is simply a series of numbers, like 3 or 4 series of numbers would be given to you, and you would be asked what would be the next in the series. And there are various other patterns also in this particular number series questions, but this is the most found pattern that is found in number series. So next, so this is what I would have defined in the first slide. So these are series of numbers that follow a pattern. So these aren't just random numbers that are given to you, they follow a pattern. You'll be required to guess the next number. So this is a type of the first type of the number series questions, that 4 numbers or 5 numbers would be given, and the very next that follows in the pattern would be asked from you, or you will be finding the missing number. This is also another pattern wherein there are 3 or 4 numbers are given, and the middle one out of those would be removed, and you will be asked to find the pattern of this. This is a particularly a bit more difficult as compared to the first here in the first case, and this requires a bit of practice in the first case so that you could easily do the second case with comparative ease, and find a pattern from the series and then select the one that matches. And this is the third type of question which are usually asked in exams that are difficult as compared to CRTs, but this again simply requires the knowledge of solving the first one, and then there will be 4 options given to you for 4 or 5 series are given to you, and after selecting the first pattern, after understanding the pattern that is there in the first that is in the question that is given, and then you need to select the options, that which option fits there, and naturally you need to select that particular option. So we are finding a pattern from the series and then select the one that matches with the options that is given there. And now you need to build the next one would be to build a number series from the same pattern in the question. And this is something like this: you find the pattern first of all, and then you build a number series. And so basically there are 2 number series given to you. In the first series there will be the natural series that is given in the question, and the second one some parameters or some numbers would be given, and you will be asked to calculate the others based on this particular pattern. So this is also kind of a new pattern that is coming out in the questions that we see in the campus recruitment trainings. So different methods to spot the patterns. So how do you solve a number series question? These aren't just random numbers that are given to you. There has been a pattern that is already set, and according to these patterns you can follow an algorithm. I would suggest to always take the difference first between the consecutive numbers. So consecutive numbers would mean like 2 numbers that are side by side or adjacent to each other. So these two, and these two can be considered as consecutive numbers, and consecutive terms, that would be the better terminology here. So check for double difference. When the first one doesn't work out, you go for the double difference, and if that also doesn't work out, you next go to the next step, that is check for squares or cubes differences. So what is a square or a cube difference? Simple means it simply means that the difference wouldn't be the either increasing or decreasing order, it would be in the square or cube pattern. And the next one would be check for combination of all the 3 situations above. So what happens in this case is that to make it more complicated and tough, out of 3 or 4 questions in the exam, he'll be giving you a question wherein that a question would be requiring the knowledge of all these 3 concepts. And so these 3 situations together, if you put it into a particular perspective, you'll get the answer in this particular question. So this is considered a tough question there. And check for submultiples or multiplication or fractional multiplication to terms. So what this means is that sometimes instead of doing a simple multiplication or a simple addition, he does a partial or a fractional multiplication to the question, and also a multiplication and the sum with a number. So this is another pattern, relatively difficult as compared to the fourth one. And this is fairly easy if you know the prime number patterns, and you could also put in differences there accordingly. And this is a special pattern that is found in reasoning questions, that you have previous terms, addition or difference in groups. So 3 or 4 terms or 2 terms or even 4 terms are like they are grouped together, and their sum is the next term or the previous 4 terms, and so on. So this is kind of a grouping scenario. So let us start with the first difference method. So a difference method simply means that I take the difference of the two consecutive terms. And so suppose if we take 3, 5, 7, 9 and 11. So these are just odd numbers, so that you could have figured out by this time. So the difference remains the same here, that is 2, 2 and 2. So naturally what will be the next term? The next term will be simple addition of this with this. So 11 plus 2, that gives me 13. So this is your answer for the first question. Now next, this difference could be either in increasing or decreasing order. So the second question simplifies in this way. There is negative 5, negative 5 and negative 5. So your answer now will be -1. And the third question, you can see the difference here is 47, 60 minus 47, that will give you 13. 74 minus 16, then this is 14. And this is 15. So your difference is actually increasing. And if you do the next concept, that is the double difference, you can see here there is a difference of 1 and 1. So now my next term would be 15 plus 1, that will give me 16. If you add 16 to 89, this will give you 89 plus 6, that is 95, plus 10, that is 105. So 105 would be the answer for this third question. So have you we would have understood the difference method. Well, as soon as you receive a series, always calculate the difference between the consecutive terms to get a basic understanding. And if it is an easy question, we will directly solve that question using the difference method. Then comes the double difference method. If you have failed analyzing using the first method, then you go to the double difference method. What does this mean? You take a difference for the first stage. Suppose if you do this particular question, this is 2, 4, and so you can see here that this is a basically doubling of the previous term. So this is again a special pattern. You could have figured it out by this now, but I want to demonstrate you another perspective here. So 16 and 8 difference would be 8, 32 and 16 will be 16, and the double difference would give you this one, 2, 4, 8. And this is simply doubling of the same. You could have done the same in the previous one, but if you go for another difference, that is 2, 4, and this becomes 2. So this seems to be quite complicated now, but again, if you, these are simple numbers, so you can easily figure out that this is a doubling of this one, and 4 would be doubled up to 8 and 16 and so on. So naturally the answer has to be 64. But what is the perspective of doing this particular format is that sometimes the questions are difficult, and you need to go to a next level of difference, so that you could understand what is the pattern that is running behind in this particular number series. So 2 plus 2 will be 4. So next one will be 6, because the difference remains that 2 here. So this will be 6. So 8 plus 6, and this will be becoming 14. 14, so 32. So this makes it 16, and so the answer would be 64 again. And this would be demonstrated clearly in the second question. So let's start with the second question. 6, 13, 27, 48, and what is the answer here? So if you do the difference, like 6 and 13 and 6 difference would be 7, then it would be 14, then it would be 21, and what will be the next term? So you do the simple double difference, that is 7 and again 7, and now you can easily figure out that this is a multiples of 7s are running here, and 21 plus 7, that will give you 28. Add 28 to the previous term, so 28 plus 48, so 48 plus 8 will give me 56. 56 plus 20 will give me 76. So 76 is the answer here. Next, in the third question, it is also based on the double difference method. So 88, 64, 46, 34, 28. And this is you would have figured it out by now that this is a decreasing series, and this would mean 24 would be difference here, and this would be 18, this is 12, and this is 6. So, and consecutive difference is all, you can see here it is 6. So what would be the next difference? 6 minus 6, that will give me 0. So the next term is also 28. same as the previous term, because the difference now becomes 0. So here the answer is 28. Here it was 76, and here it was 64. So this was how you can do the double difference or even multiple differences in levels, so that you can figure out what is the constant term that is running behind in the series. These are simple questions, but sometimes questions can be complicated, and this can be easily solved using the double difference method. Now we come to the next concept that you can utilize to solve your number series is squares or cubes. Sometimes the first three methods don't work, and then you can analyze using the squares or cubes method. This is 2, 4, 16, 256. And one specialty that you will see in squares and cubes is that the numbers will rise very quickly. That is 2, 4, 16, and then it jumps to 256. So you can see here that the difference won't work out in this case. So this is simply 2 square is 4 and 4 square is 16. 16 square is 256, and the answer would be the 256 square. So you need not calculate. You can use the unit squaring method. So 6 square, if your options are having terms like in the last digit as 7 and 6 and 4 and 2, suppose these are the some terms that you have been given in the answer, so this won't be a 3-digit answer here, but you can figure out that 6 square is obviously 36, so your unit digit should be 6 here, so this would be your answer. So you need not calculate 256 square, and this is just to check your presence of mind in exam. So you can use the unit term squaring method. So you can figure out that 2 square was 4 and 4 square was 16 and 6 square is 256. That is, now the next term unit digit should also be 6. So this is some kind of a shortcut that you can use for calculating the next term. And if options are given, that makes it relatively very much easy. Sometimes options are also not given in exams. So that is a different thing there. And now we'll move to the second question. Now this question is like this is 1, 1, 2, 8, 3, 27, 4, 64, and so on. So when you see it for the first time, it is like very complicated. It's like numbers are increasing up to this point, and then it decreases, and then it starts again increasing. But again, if you take two terms at a time, like, and then you can find a pattern here, that 1 cube is 1, so this is the first one. 2 cube is 8, 3 cube is 27, 4 cube is 64. So what will be the next two numbers? That is 5, and the the cube of 5, that would be 125. So answer is 5, 125. So sometimes more than one terms could also be asked. So natural cue that goes here is that these numbers would be forming a pattern with two numbers taken at once, and so this is how you can actually solve this question. This is a difficult one if you don't get that concept of picking up two at a time. And so when you move to the next question, that is question third, and now you will figure out that these numbers are increasing very sharply, that 5 goes 10, then 35, then 660. So something that related to squaring or cubing is going on here. And let's take the difference for the first term, 5, and this is 25, and this is 660 minus 35, that will give me 625, yes. And so you can figure out here that 5 square is 25 and 25 square is 625. So next term would be the square of 625. 625 squared plus this term, that is 660. So this will be your answer. So again, a shortcut that you will see here is that terms with ending with 5 square, that means the unit digit of the answer should be 5. So this is a cue here that you can use, that if there are 4 options and one of them has 5 and the others have like 1, 2 or 3 or other numbers, so you can select this particular answer here because the unit term matches there. So this was, in some ways you can use squares or cubes, and there are also other patterns, but you get them with practice. Like if you are there's a general algorithm that you start with the difference method, then go to a double difference, then pick out squares or cubes, and now this is a tougher one, that is the combination of all three. So you have practiced the first 3 steps. Now we look at the combination of all the 3 steps. So the natural algorithm that you can use is that always find the difference first and then figure out the combination of all the three that you have used earlier. So 2, 7, 32, 157. This is the first question that we are doing, and you ask the next term now. So 2 and 7, the difference would be 5, and this is 25, and this is 125. So the difference runs like 5 power 1, 5 square, 5 cube, and now 5 power 4. So increasing what we say, the exponentiation of the term 5. So 5 power 4, so you can do 125 times 5, this will give you 625, and 625 if you add it to 157, this will give you the answer here. So 5 plus 7, 12, and you can do the calculation. But again, the first thing that you need to understand is that always calculate the differences first. These help you to analyze the terms that are written over there, and if these sharply increasing terms, these are terms are increasing and they are sharply increasing, like 2 becomes even more than double, and 7 becomes even more than 4 times, and 32 becomes almost 5 times. So this is a cue here that there is something related to squares and cubes going on. So that in that way you can analyze the first question. Now we move to the second question. This seems to be a rather easy if you understand the cubing of numbers. So 125 is 5 cube, 64 is 4 cube, and 27 is 3 cubes, and 8 is 2 cubes. So if you are familiar with these numbers, if you remember the cubes, then it's very easy. Otherwise you'll figure out by using the difference method. So what is the difference here? That will be like 61, and the difference here is 27 plus 7, that will give me 34, and this is like 37 is the difference here. And then what is the difference? That is 19. Now if you don't understand what are these numbers, like in special cases where the numbers are big, you won't be able to figure out that whether it is a square or a cube. So we go for double difference. Now see what happens here. This will like 37 plus 4, that will be 41. So 41 and 20, so this is like 24, and 19 plus 8 will give me 27, and 10, so 18. So if you do the difference here, this will be like 18 plus 6, 24, and you reduce 12 here now. So 24, 6, so 18, if you do the difference, it will give you 12. Now reduce 12 from 19, this will give you 7. Now reduce 7 from 8, this will give you 1. So in this case, it was 1 cube was your answer, and it was 1. And after doing the double or triple difference, you are getting the same answer, that is 1. So this is the importance of using double difference or even multiple differences levels. This helps in solving number series in a much easier way. Now let's move to the next question, that is question number 3. This seems to be again something that is a combination of all three. Obviously the title here is written as combination of all three, but how do you figure out that it uses most of the concepts that we have already learned? Again, it's the same thing. 1 becomes 9, 9 becomes 36, and 36 becomes 100. So this is a jump of almost 3 times here, 4 times here, and 9 times here. So if you start doing the double difference or the differences between the consecutive terms, this becomes 1, 9, 36, and 100. That is the question here. And difference is 8 here. Then difference is 27 here. Difference is 64 here. Now if you are very good with numbers, that is a cubing of numbers, you will figure out that this is 2 cube, this is 3 cube, and this is 4 cube. And what will be the next term? That next term will be like 5 cube, and that becomes 125. Add 125 to 100, this becomes 225, and that is your answer. But if you don't remember this particular thing, next you could have done one more line of difference, that is 27 minus 8, this becomes 19. 64 minus 27, this we have done earlier, this becomes 37, and now this becomes 19 plus 18 will give you 37. So the next term would be like since it is increasing, this has to be 19, and this will become 9 plus 7, 16, 1, 3, 4, 5, 56. If you add 56, to this one, was this 56? Yes, it was 56, and 56 if you add it to 64, it will become 64, 6 plus 4, 10, 6 plus 6, 12, 120. If you add 120 to this term, so this should be 125. I've gone wrong somewhere. So again, let's do it again, like 8, 27, 64, and then we need to find out the next term. So 8 plus, this is 19 plus 8 will give me 27, and 7, and this is, since 5 goes off, 3, 37, and this was 19 plus 8 will give 27, so this will be 18. So if we term again 18 here, so this was not 19, this is supposed to be 18, and this will be giving me 8 plus 7, 5, 3, 4, 5, so this will be like 65. If you add 60, 37 plus 18, 8 plus 7, 15, 3, 4, 5, 55. This will give me 55. 64 plus 55, that becomes 9 plus 5, 119, and 119 to 100, and this will not work out. So sometimes the difference doesn't work out, so you need to use this old logic that 8, 27, and this was 36, and this will be like 64, 4 cube. Next term is 5 cube. 5 cube will become 125. 125 plus 100 will give you 5. 225 is your answer in this case. So let's move on to the next one, like check for multiplying factors. And whenever you see questions with decimal numbers, like 4.5, 6.5, 1.5, 0.75, 2.5, 3.25, 3.625, whenever there is a decimal number, that is a clear indication that there is something that has been used as a multiplying factor there, and that would make the problem easier if you actually divide the terms instead of calculating the differences. So let's start with the first question. So 2, 3, 4.5, 6.75. So what is the first two? If you divide the second term with the first one, this will be like 1.5. Divide the second with the first one, it's again 1.5. 6.75 again with 4.5, it will again give you 1.5. You can use the calculator for this thing. And next, what will be the next term? Simple. You multiply this term with this term, that will give you the answer here. Now we jump to the next question, and this looks something again on the same lines, but instead of multiplying it with a factor, it has been divided with 2, that is 6 divided by 2 will give you 3. 3 divided by 2 again will give you 1.5. 1.5 divided by 2 will give you again 0.75. Divided with 2 to get your answer, that will be 0.375. So this is your answer in this case. So just simple multiplying and dividing with factors is also a concept that is used by examiners to ask questions. And now this is a question wherein you might be needing multiplication and also addition. So 1, 2.5, 3.25, 3.625. So when you have figured out that this is some kind of a addition, and this is not multiplication, because if you do multiplication of a very large number, the scale should go up like exponentially, but this is something that has been multiplied, and also there's some kind of addition also is involved. How can I say that? Because the terms are like nearby, 1 to 2.5 and a jump again, so it is kind of a linear scale. So if you check out linear scale, y is equal to mx plus c, there has been a multiplication factor and also a constant that is being added. So in this way you can figure out that this is a so let's do the difference. Let's start with the basic thing. Let us do a difference. 2.5 minus 1, this will give 1.5, and 3.25 minus so this is like 0.75 is the difference, and 0.4 nearby 0.4 is the difference. So how do we do this one? So if you just do the double of this, so this becomes 2, 5, 3.25 double is 3 double is 6, this becomes 6.5, and this is 3.6, and this will be 72. So somewhere around 13, sorry, so 3.625 multiplied with 2 is like 5 to the 10 to the 4, 5, 6 to the 12, 1, and 3 to the 6, 7. So 7.25 is the next number. So what we have done, we have multiplied with 2 the whole number series. So whenever we get the answer, we need to divide it with 2. So this is like the difference now 3, and this is like 1.5. And what is the difference here? And this is like 0.75 the difference. So 3, the difference become half of that, and then half of that. Now we do half of this difference. 0.75 half would be 0.36 365 something. 37 and a half is the number. So 0.375 is the number that comes up here. And now we add this number to 7.25. So 7.25 plus 0.375. 5, 7 plus 5. This will give me 12. 3, 4, 5, 6 and 7.625. So the next term is 7.625 divided by 2. Why am I dividing with 2? Or remember, we had multiplied with 2 to get to this particular series. Now to get the right answer, we need to divide it again with 2. So 3 to the 6, 1, 6, and sorry, 8 to the 16, 1, 2, 5. So this is like somewhere around 3.8125 is the answer for this particular question. You can check the answer for accuracy. And let's move on to the next. So sometimes it happens that instead of giving a particular difference for numbers, like a constant difference or a increasing difference or a multiplicative difference, so they give you prime number difference to actually make it somewhat more complicated as compared to the previous one. So like start with the first question, 2, 3, 7, 17. So if you try to calculate the difference, like 1 and this is 4, and what is this, 17 minus 7, that will give you 10. So this is 3. It will go for double difference. You didn't understand this one. 6, and suppose if you do 3 plus 6, 3, so 3 here, so this was 9. So this is 10 plus 9, this is 19. So if you put a 19 here, your answer will be wrong, because see what is happening here. Your first prime number is 2, next prime number is 3. Okay, now he has skipped one prime number, 2, 3, 5. Now he has put here 7. Now next prime number is 11 and 13. So 11 he has skipped, 13 he has skipped, and he has kept here 17. So next prime number is obviously 19, but if you keep 19 here, it would be wrong. And suppose it becomes 19. So I've done some mistake. I can 9, 19, and 19 plus 17. This will be like 36, which is again not the answer because 36 is not prime. And so 11, 13 you have skipped. You got 17. Then you go to 19, 23. What is the next number? 29. Okay. And the next number would be 31. So 31 is the answer here after skipping 3 prime numbers. So first prime number, then you gave the second prime number, so difference is 0. That is 0 prime number difference. So there is a 1 prime number difference and there is a 2 prime number difference. Then now we have 3 prime number difference to get the answer of 31. And now let's move to the next question. The 41, 43, 47, 53. What will be the next number? Yes, you have guessed it right. It is 59. For this, you need to know the prime numbers from 1 to 100. It will make it very easier to solve this question. If you go with the double difference, this doesn't work here. So 41 plus 2, 43, 4. And what is next? 47 plus 6, 53. So what should be the next? 2, 4, 6. So this becomes 2 again, 2, 2. So 8 will be the difference. 8 plus 53. And 53 plus 8 will give you 61. So 61 will be there in the options, and if you mark 61, your answer will be completely wrong. And so 59 is the answer here if you are considering this one to be a prime number series. Next, sometimes prime numbers are hidden in your series. So like if you do the difference here, 2, 3, 5, 7. So if you see 2, 3, 5, 7, the next number would be obviously 11 if you know the particular series there from 1 to 100. So 11 plus 18, and this will be like 29. So 29 is your answer in this case. So sometimes go for prime number differences as well. It makes the task easier. And if the particular question has been you're not getting answer directly after doing the earlier steps, once check for prime number differences. Sometimes it does work out, and most of the times it is a thing that is used by examiners to confuse the candidate, and he'll be keep on solving using the double difference, the squaring, cubing, and he'll apply everything like even multiplicating factors, but he will not get the answer, and he'll be spending a lot of time. But if he could have utilized prime number differences, the task would have been easier, well, given that it was based on prime number differences. So this is the last one, last method from my side, wherein we do the previous terms addition or differences. Happens in reasoning, wherein the previous two terms would be the sum of those two terms will give you the third term, or previous three terms will give you the fourth term, sum or difference. And this is a concept that is used in government exams as well. So let's start with the first question. So 1, 2, 3, 5, 8, 13. So what could be the pattern here? So the difference is 1, 1, 2, 3, and this is 5. So it doesn't make any sense, right? Even if you start doing the differentiation and double differentiation, it doesn't work out. So if you have like if you know this concept like previous terms of grouping of terms, 1 plus 2 will give you 3, 2 plus 3 will give you 5, 5 plus 3 will give you 8, 8 plus 5 will give you 13, and 8 plus 13 will give you 21. So this is your answer. So same goes for the next question, but here instead of like 2 terms at a time, we are taking 3 terms at a time. So 1 plus 2, 3 plus 3 will give you 6. Now 2 plus 3 plus 6, that is 6. Sorry, 2 plus 3, 5 plus 6, this will give you 11. And now the 3 terms, 3 plus 6, 9 plus 11, this will give you 20. And 6 plus 11, 17 plus 20, this will give you 37. Now the next one is a simple addition of previous 3 terms. So 11, 20, 37, this will be like 8, 3 plus 2, 5 plus 1, 6, 68. 68 is your answer. So this is how you can have done the previous terms grouping. And the last question is in the somewhat complicated. This could be done using the difference instead of doing the addition. So 125 minus 64. So if you directly see the numbers, like 125 goes to 64, then it goes to 61, then comes an anomaly that wherein it goes to 3 and then it jumps to 58. So this could be like complicated, like people would start figuring out into 1.5 or 0.5 an addition of something, but this is a simple kind of a scenario that 165 minus 64 will give you 61, 64 minus 61 will give you 3, and then 61 minus 3 will give you 58. So what will be the answer then? That is 3 minus 58, that is equal to minus of 55. This will be there in the option, and once after seeing this option, it will outrightly reject this option, because how can it be negative after some 4 or 5 terms? So but if you apply this particular previous terms addition or differences in group, and this again is out of the box, but sometimes to get those extra marks you need to apply everything, because you will be solving the complete paper and then you will come to those 2 number series questions that you weren't able to solve, and some out of the box thinking could actually make you solve those questions in just a matter of seconds, where others would be struggling with those 2 or 3 questions that are remaining. So this some kind of like out of the box thinking is also required in our jobs as well, and that is why the examiners put in these type of questions too, so that they could figure out people who could think out of the box, and those would be like cream of the organization. And that is where our businesses and other institutes, they figure out how to run their uh, whatever we can say a lot of our these things. But again, these are just number series, and you can apply there are other techniques as well, but to start with, you can start with this particular uh, questions. And this is me, Ankush Bansal, signing off for the video. Please do watch CRT for Placements channel for more such videos, and thank you all for your support.